Hello to all of our customers out there. This morning, I'm talking to Wayne, Ben, and Pavel in our engineering group here at Anderson Global, and I've asked them to just take me through how we approach simulation here at Anderson and what benefits it can bring to our customers and how it helps give a better solution at the end of the day for those customers. So good morning, guys.
Morning, Mick.
Morning, Mick.
All right, so I think, Pavel, you're going to get us started with a quick high-level run-through of what we do. So please go ahead.
Sure. Yes, Mick, when we approach simulations, we usually start from DFM and then have multiple layouts to figure out, how the casting is going to be made. And depending on the complexity of the casting, it takes quite a few tries sometimes to get it figured out. We start with design for manufacturing, which is usually done by Ben Flower, our engineering manager, where he analyzes the casting for backdrift issues, core package issues, how the partings are gonna look, and things like that. And then we start laying it out. And here's an example of just a very simple layout to where we start running, very first simulation, and start switching things up to based on the results.
Mm-hmm.
So
this is right at the beginning. This is the first thing you do. Let's have a look at what the most simple solution looks like, because of course simple means lower cost and easier to make. You want to be simple if you can, and better yield. But
correct. Yep.
Yeah.
That we definitely start simple first, and mainly that is for post processing, in the foundry, less gates to degate and things like that, and less things to grind.
Yep.
Degate. And so those are just examples of layouts to where we switch things up, and on this particular example, things get a little bit more complicated because maybe we couldn't achieve velocities, desired velocities, or there's undesired velocities or cold shots. So those are just examples of how we progress to a finished layout.
Right. So when you say a desired velocity, so too high a velocity introduces potential turbulence. Am I understanding that correctly? Yeah.
Correct. Turbulence and trapped air. Yep.
Yeah.
So yes, it's on this particular example, we had like 7 layouts to get to a final, to get to the final one that customer was happy with and we were happy with.
So what we're looking at here is different potential gating designs, mostly. If
yes.
I've got terminology correct, I'm not seeing any risers. Yes.
There's risers here, but yes, typically it's casting orientation is where it really comes down to which side is at the bottom in the drag half, which side is at the top half, hope half, and different customers have different preferences. But it's the number of runners. Sometimes it's a double runner, sometimes it's a single runner system. Gate sizes, riser sizes. So as you can see, like I can scroll to the very first slide, Mick. This is a very simple, just one pour cup, just feeding directly into the casting, which is called a direct pour. Same this one, just trying to keep things simple, but we were not achieving what we wanted. So we had to switch things up. We fed this casting from the bottom.
Right, and then presumably the size of those gates to get in there are going to be critical. They obviously create material yield, bigger issues to remove afterwards, but at the same time you can play with different sizes and get different results. Yeah.
Yes.
Okay.
Yes, definitely. That's something that we calculate these things. So we have formulas for gating ratios. There's different standards and for different casting processes, but yes, that's something that we calculate for each shot.
Now this is a tilt pour process that we're looking at here, I think. Presumably we can also model different other types of processes, right?
Yes, we can model up pretty much most of the casting processes, or tilt pour, static pour, sand, green sand, printed core packages, reverse tilt, low pressure. We can do pretty much development of the layout for any of these processes. Yes.
For customers listening in or watching here, we've built all of those types of tools here at Anderson over the years and have plenty of experience around that. So.
Yes.
Okay, so that's kind of the overview.